Welcome to this GCSE Science tutorial video on calculating percentage yield. For most exam boards, this is a triple science higher tier topic only. If you would like help and support with GCSE Science going forward, then please subscribe to the Genius Science YouTube channel and remember to follow us on TikTok at Genius Science 1, where we post short videos daily. The percentage yield of a chemical reaction is an important thing to consider in the chemical industry. This is because the percentage yield is a comparison of the yield or quantity of product actually obtained compared to what could have been obtained in theory without any waste. The formula to calculate percentage yield is the actual yield divided by the theoretical yield times 100. Now, the actual yield is defined as the mass of product actually produced in a chemical reaction. The theoretical yield is the maximum mass that could have been produced if there were no waste. And there are a few reasons why percentage yield is always below 100%. They are, number one, an incomplete or reversible reaction. Number two, there could be practical losses such as through filtering or pouring. And lastly, three, there could be side or unwanted reactions that compete with the main reaction that you're carrying out. Calculating percentage yield actually involves multiple steps. So let's run through them. Step one, we calculate the amount in moles of the required substance. And we do that using the moles equals mass over relative atomic or relative formula mass. Step two, we calculate the maximum amount that could be formed using the molar ratio. Step three, we have to calculate the maximum mass that could be formed. That's the theoretical yield. And finally, step four, we calculate the percentage yield using the formula that we have just gone over. Now we're going to go on and apply this method to some typical exam style questions. So here's our first exam style question. A displacement reaction was carried out where copper was displaced from excess, that means more than needed, copper 2 sulfate solution by adding 12.8 grams of zinc. The copper was then filtered off and dried and 8 grams of copper was obtained, and we need to calculate the percentage yield. Now before we go into our method, we first need to circle on the balanced equation the important bits of information. So we have here 12.8 grams of zinc, so we just circle zinc and then we can write 12.8 grams. And then with copper we have 8 grams, and that's all we need to care about in this calculation. And this 8 grams is our actual yield because that's what was actually obtained. Now we can go on to carrying out the calculation. So step number one, we need to work out the number of moles in 12.8 grams of zinc, and using our equation moles equals mass over relative atomic mass because we're doing it for zinc, and that's moles equals 12.8 grams divided by 65, the relative atomic mass for zinc, giving us to three significant figures, 0.197 moles. Now the next stage, looking at the molar ratio, so look at the balanced equation, they react in a 1-to-1 ratio, so whatever number of moles of zinc you have, we have the same number of moles of copper, so 0.197 moles of copper. And step number three, we need to find out the maximum mass of copper obtained, so the theoretical yield. And again, we're using moles equals mass over relative atomic mass. So substituting in our value for the moles of copper, 0.197, equals mass, because we're trying to find it out, divided by the relative atomic mass of copper, which is 63.5. We now need to rearrange for mass, so multiply both sides by 63.5. We cancel out, so the mass is equal to 0.197 times 63.5, giving us a maximum mass of copper of 12.5 grams, and that 12.5 grams is, just going to circle it there, our theoretical yield. So that's the maximum possible that could have been obtained. Now the last step is to calculate the percentage yield, and that is the actual yield, which is 8 grams, divided by the theoretical yield, which we just found out is 12.5 grams, times that by 100 to find a percentage. That gives us a percentage yield of 64%. Let's now go on and do another example. So here's another slightly harder example. So we've got the balanced chemical equation for the electrolysis of aluminium oxide, and a scientist electrolyzes 2,500 kilos of aluminium oxide and obtains 850 kilograms of aluminium, and we need to calculate the percentage yield of aluminium. So first of all, circling our important info, we have 2,500 kilos of aluminium oxide, but we need to convert it to grams. So we have 2.5 million grams. Don't be surprised by the large amounts in industrial chemistry. And for aluminium, 850 kilograms in grams times in by 1,000 is 850,000 grams. We're doing this because the mole equation, the standard units are grams. Now, that's our actual yield, the 850,000 grams. We'll come back to that later. Now, step number one, we need to work out the number of moles contained in 2.5 million grams of aluminium oxide. So using our equation, the number of moles is equal to the mass, which is 2.5 million grams, divided by the relative formula mass of aluminium oxide, which is 102. And that gives us 24,510 moles of aluminium oxide. Now, using the mole ratio, we need to work out the number of moles of aluminium. Now, notice that it's a 2 to 4, so that means there's going to be double the number of moles of aluminium than there are of aluminium oxide. So what we actually have to do is take 24,510 and times it by 2, giving us 49,020 moles. Now, step number 3, we need to work out the maximum possible mass of aluminium. That's the theoretical yield. Again, using our mole equation, we have 49,020 moles of aluminium, which is equal to the mass, because we're trying to find out, divided by the relative atomic mass of aluminium, which is 27. Now, rearranging for mass, we times both sides by 27, cancelling out, giving us the mass equal to 49,020 times 27, giving us a maximum possible mass, therefore a theoretical yield of 1,323,540 grams. And remember, that's our theoretical yield. So now on to step 4, our last stage of the calculation. So calculating the percentage yield, which is the actual yield of 850,000 grams. That's what we actually got, or what was actually got in the experiment. Divide that by our theoretical yield, so 1,323,540 grams, and multiply that by 100, gives us the 3 significant figures, a percentage yield of 64.2%. And now we're going to go on to one last example before we end the video. Right, so the last example, we have the Haber process, which combines nitrogen from the air with hydrogen to form ammonia. And this is a reversible reaction. A scientist reacted 20 tons of nitrogen gas and obtained 4 tons of ammonia. And we need to calculate the percentage yield. Now, again, we need to make sure that we know what we're working with. So we need to circle the bits of relevant information. So 20 tons in grams is 20 million grams, because there's a million grams in a ton. So we have 20 million grams of nitrogen gas. And ammonia, again, 4 times a million gives us 4 million grams of ammonia. And that is the actual yield, because that is what was obtained. Now we go on to step number 1, where we have to work out how many moles is in 20 million grams of nitrogen gas. That's moles equals mass over relative formula mass. So the number of moles is equal to 20 million. Divide that by the relative formula mass of a nitrogen molecule, which is 28, giving us a whopping 714,286 moles. Again, in industrial chemistry, don't be surprised by these high figures. We need to produce a lot of product. And then looking at the molar ratio now, you can see whatever number of moles we have of nitrogen, we will have the same number of moles of ammonia. They have the same multiplier. Therefore, we also have 714,286 moles of ammonia. Now we need to work out the theoretical yield, so the maximum mass, which is the mass of 714,286 moles. So using our equation again, moles equals mass over relative formula mass. We have 714,286 moles, which is equal to the mass, which we're trying to find out, over the relative formula mass of ammonia, which is 17. We now need to rearrange for mass, so we multiply both sides by 17. And then we cancel out, giving us mass being equal to 714,286 times 17, giving us a mass of ammonia, a maximum mass, a theoretical yield of 12,142,862 grams. Again, just so we know exactly what we're dealing with, I'm just going to label that here, theoretical. And then lastly, now we need to calculate the percentage yield of this reaction. So remember, percentage yield is actual divided by theoretical. So our actual yield is 4 million grams divided by the theoretical we just calculated, so 12,142,862 grams. We multiply that by 100 and into 3 significant figures, giving us a percentage yield of 32.9%. If you've made it to the end of the video, then you have discipline and are destined for a bright future, so well done you. You deserve a reward. Email us at geniusscience1@gmail.com with the subject of the email titled percentage prize, and I will send you over some free revision resources on percentage yield so you can get in some extra practice to get those top grades. So thank you for choosing Genius Science, and remember to work hard, be kind to others, and we look forward to seeing you in the next video.